Well, good afternoon, good evening, or good morning, depending upon where you are in the world today. And welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great webinar on tap today, lots of interesting information, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the webinar, you will be able to access it on demand. Following the webinar this afternoon, we should be sending out an email that will contain a link that you can click on to access the webinar. And we are taking questions from the audience. So at any time during the presentation, if you have a question for our panelists, please don't hesitate. Use your GoToWebinar control panel and submit your questions. And we'll take probably about 10 or 15 minutes or so near the end of the presentation and go through the audience questions. Okay, with that, we will go ahead and start today's webinar, which is the future of DevOps observability, the evolution of logging, monitoring, and metrics. Our speaker today is Norman Shea, who is head of business development at LogDNA. Hey, Norman, how are you?
Very good.
Good, good. Well, thanks for joining me. I am going to put myself on mute and let you do your thing.
Awesome. Thank you very much, Charlene. Hi, everybody. Like Charlene had mentioned, we'll be going over the future of DevOps observability. I know it's a mouthful. It's definitely a term that's being passed around more and more to encompass things like logging, monitoring, and metrics. And we'll talk briefly about where we are as a company, and then we'll kind of dive into sort of the evolution that we're seeing as we sort of are pioneering some new technology around the multi-cloud logging space, and we'll talk about that a little bit more as well. Just to go back to the reference, my name is Norman Shea. I run business development for LogDNA. I know that business development means a lot of things. For LogDNA specifically, is I deal with a lot of our integration partners, such as infrastructure players such as AWS, GCP, IBM Cloud, Azure. We look into a lot of these marketplaces because that's where DevOps intelligence and DevOps observability is highly needed. And so we partner with a lot of those folks. And so get to talk with a lot of the folks in the industry. A great place to be, a lot of exciting stuff going on, especially with things like Kubernetes. Let me tell you a little bit more about LogDNA as a company. We started around 2015. We graduated from a program called Y Combinator. Some of you may have heard. Some of the larger sort of alumni in that space are folks like Airbnb, Dropbox. So definitely tons of interesting large companies that have grown out of there. We're excited to be from Y Combinator, and we've gotten a lot of use out of being out of Y Combinator as well. So we launched around 2015. We've been running a multi-tenant SaaS version of our solution for the last effectively 2.5, 3 years, and we've gained about 2,000 companies. Some of the larger partners that we have partnered with today, IBM Cloud, we've just announced a partnership with them probably about a couple months ago, where we are helping them provide a log solution directly on IBM Cloud, and that will actually be for all their customers that using IBM Cloud today, so that they don't have to use, when they're thinking of a SaaS product, they don't need to actually, they can actually keep all their data within the infrastructure that they sit on. Rogue is another big partners of ours as well. And then obviously there's a list of customers, and I'll go through 2 use cases later, or 2 customer scenarios that we'll talk about later at the end, towards the end of the presentation. We won't spend too much time on that. Just a couple highlights, just to prove that we do some pretty interesting stuff. We are a log management solution. We, some of our smaller customers range anywhere from 100 megabytes a day, and this is in terms of ingestion, how much they send to us. And some of our larger customers, there's a typo there, but some of our larger customers will log about 20 terabytes a day. So a huge, vast difference in terms of the variance of how much logging that they have. And that's one of the things. It's really difficult to tell sometimes how much you are logging and how much you are planning to log, but it is something that we'll work with customers to figure out what that need is. And then a cool fun fact is we ingest more daily data than YouTube. So I don't have the exact number of what that is, but it's just a fun fact that I think YouTube published how many terabytes they ingest in a day in terms of data that's created, and we do a lot more than that. A couple of the fun things are our average live tail latency is 1 second. What that means is that from the second that you send your logs into our solution and we ingest, we actually will pipe that back out to you. So you'll see your live tail in less than a second for most cases. Obviously sometimes there's higher load and it may increase or decrease, but that's kind of our average live tail latency. And then our average search speed is around 200 gigs per second. Now, again, this is one of those things where we've calculated an average. It's not an exact science in terms of what that is. It depends on what the data is and how we index that data, but just giving you some nice fun facts that we deal with. A couple of reasons why, or a few reasons why we created LogDNA. We really wanted a modern logging technology, which we couldn't find at the time when we were building this out, which was developer first. And it's important to us that it's developer first because there are many tools out there that are just technical tools, but they don't really consider the developer first. A couple of good examples of that is when you install our product, everything is effectively command line copy and paste, meaning that all you have to do is copy and paste that direct command, and we'll include any tokens and ingestion keys in the examples that you have to actually input, so you don't actually do anything. It actually is really a maintenance-free kind of product for you. The next thing we want to do is provide a zero downtime product. What that means is it's more of the vision of the company is we wanted to build a product that lets you access your logs as soon as possible to prevent any downtime from occurring within your own system. The third point is build for scale. If you've ever used Elk before or built built your own kind of in-house logging solution before, it's really easy to get them set up because technically there's not a whole lot. You're ingesting some unstructured data, and then you're doing some searches on it. But if you're actually building for scale, if you're talking about folks that are doing anywhere upwards from terabytes to 20 terabytes, and then we've talked to enterprise customers that go even further beyond that and need kind of their own infrastructure to handle that, that scale needs to be built out there. And part of what we do, which is great, is we are a cloud native solution, which means that from a scalability perspective, we have been able to scale with a lot of the cloud infrastructure that's out there today and take advantage of what's out there. We're not just a VMware image that we plop on somewhere. We're truly a cloud native solution that runs on Kubernetes. Lastly, we wanted to create LogDNA because we luckily made a bet on Kubernetes, and we have that flexibility of deploying not only as a multi-tenant SaaS, but I talked about cloud native, and we'll talk a little bit more about multi-cloud later on. That flexibility allows us to go on-prem in a multi-cloud scenario where you can actually have services running in multiple different infrastructures, and also obviously a multi-tenant SaaS, which is what the majority of our customers are using today. All right, so going to the topic of the future of DevOps, observability. So one trend that we've been seeing is that DevOps are going to be really busy, and I think that's to no surprise, but just some of the key historical things that have happened in the last few years, last decade, last 2 decades. There's been a lot of technology evolution, and that evolution will come with new tools being born, and it's part of why we're here today. So if we jump all the way back to 1999, about 20 years ago, VMware launched. And why this was a big deal at the time was, VMware ships its first virtual platform. So you're effectively taking logs from a single system, and you're now saying, hey, I can take that single server and split that up to multiple different VMwares, and I can have different operating systems running on there. And then effectively, I can optimize my server load and optimize my actual infrastructure. But what that actually means for logging, from a logging perspective or a DevOps perspective, is that it gets more complicated. So that becomes more complicated. And then obviously in 2006, you have AWS who launches, and then all of a sudden, I don't even need to own my own servers anymore. I can just use AWS, I can use cloud infrastructure. And again, now the number of servers that I'm looking for will dramatically increase or exponentially increase, because now I can even have VMware running inside AWS. I don't need to do anything to launch a server. I can literally click a button and I'll have a server come up in 10, 15 minutes. And that was a huge game changer. And then the next thing that we see is in 2013, which is not too long ago, Docker, version 1 gets released. The interesting thing was I don't think Docker was necessarily a new idea. If you go back to 2004, 2005, when Solaris 10 came out, there's a lot of containerization that they were doing within Solaris 10, and they were building kind of zones in Solaris 10, if you're familiar with that. And that was effectively containerization at the time. It was an increased delineation from just VMware, but you were actually within a single operating system, you can actually create zones. I would say the biggest difference with that was that when you're thinking of Docker containers, the efficiency and optimization on what you need for runtime became much, much smaller. So even with Solaris 10 zones or Solaris zones, you still needed to run an entire operating system or duplicate that operating system, and you were actually still sharing resources in terms of operating system resources. with Docker containers, that becomes much more efficient because you're really just looking at runtimes that are running inside each container. So no longer do you even need to create additional resources to run a mini operating system. You're really just extrapolating from that, and you're really just making it very efficient. What that means is now you can have thousands of containers. And so soon after Docker, you see a tool called, obviously Kubernetes is pretty well known to everybody. And so Kubernetes was released, and we needed a tool to help us orchestrate all these containers. It was no longer, it's too unwieldy to try to manage containers on their own when you're having thousands of microservices running on each of these containers. And so from a trending perspective, we have a graph that we're showing here on the left-hand side. I think it's a pretty generic graph. It's no surprise that the amount of data that's going to be generated and increase is exponential. It's just not going to be a linear curve just because based on this technology that we're seeing. As you see more and more development on containerization and serverless products, we're going to see more of this expansion on data as well. So as we look at the expansion and how DevOps teams are going to be really busy, we also just historically have seen tools evolve to support new technology. So it's, technology itself is often innovated, and then obviously new tools get built to help manage that innovation. And so let's just take logging as an example, why tools need to evolve. So when you first talk about logging and you're a developer, your first session of logging is always like, you're in a console, you're developing. And even if you kind of step back several years back into the server terminal days, is the only way you can get your logs is if you could walk up to that specific server, that physical server, and log in access, and you would just look at the log files that were getting produced from your application that you're running there. Soon we moved to something a little more scalable, where you could remote access to your log files. And I think soon after that, not too long after that, people realized, well, it'd be great if I could just aggregate all my log files together. And so you see centralized logging. And so you obviously have a lot of incumbent players in the space, such as Splunk, or even just folks building this themselves, where they're just centralizing logs using syslog and then grabbing these files. But the idea was that you could then, instead of having to go to each server or log into each server to get these logs, you can now access these through a centralized location. But I think the common part about knowing with the centralized logging solution was that you sort of always knew what server you were logging into, or you had a really good idea that this server contained these logs, this server contained these logs. And you have a pretty good grasp on the logging infrastructure and where logs are coming from. I think with the proliferation of Kubernetes and Docker containers, now that becomes a little more difficult because you have containers or serverless functions that are running, and these things are basically just doing what they should be doing, and then they could be dying or terminating before you could even figure out that there's an error. So with that said, this becomes a huge scaling problem, and you need something to be able, so you need these logging solutions to be a lot smarter. So in terms of evolving tools, this is a good example that, logging solutions have to not only be a collection endpoint and just be able to search faster, they have to do things to make DevOps folks' lives a lot easier in terms of being able to determine what had gone wrong, pinpoint issues, or be able to just search which container had actually caused that error. So now let's jump into sort of what we like to think as the kind of trifecta or triforce of DevOps observability. The way that we've seen it today, and the way that we sort of, when we talk to customers in terms of what are the tools you need to really help you manage observability or the ability to monitor your entire system. And that usually boils down to three main solutions, which is logging is obviously the one we do and work on a day-to-day basis. We also have talked to a lot of partners that do APM, which is application performance management or monitoring. One or the other, they effectively do the same thing. And then you also have metrics. There's a lot of different ways to calculate metrics, and we'll talk about what we actually think of metrics, because they all sort of bundle together. You can actually use the logging tool to collect metrics. You can actually use an APM to collect metrics. Sometimes you want metrics from the APM tool. Sometimes you want metrics from the logging tool. So they all sort of mesh well together, and overall, they should be able to give you a good idea from a glance, or not necessarily even a glance, from a forensics perspective, the ability to dive into each of these tools and figure out what happened to your existing or your stack that's being deployed out there, that's running out there. So let's start with APM, and we'll jump into logging last, just because we have obviously a lot of content around logging and no logging the best. But we'll start with APM, which is application performance monitoring. So what an APM does, if you're not familiar with it, it's a tool that allows you to monitor your application in real time using pre-built instrumentation. And now you can customize some of this instrumentation, but the whole idea is generally that these tools will have dashboards, and they'll install tooling into your servers to effectively monitor your applications or your servers that are running. And so you'll be able to get things like CPU load, memory usage, network usage. These are all important things from a high level to be able to determine whether or not your applications or your servers are running the way that they do. It may or may not tell you exactly how your application is running, and that's sometimes where metrics can help better. But from an APM perspective, you want to be able to use this to determine, hey, look, my server is under load, and I can be able to do things with it. So generally what you do with APM systems is you want to set up thresholds and alerting when performance no longer looks normal, and allows you to understand how your applications are behaving to identify application problems or scaling needs before any of your users are impacted. That's the whole idea, is that you can know when something needs to be scaled, because you can determine that, hey, the CPU load on our nodes are currently extremely high, and we need to deploy more nodes to lessen that load so that none of our customers are impacted at that point. So when we look at APM, how does it evolve? So instrumentation itself is really built very specific for the infrastructure. And so I think as players have come along, there's a lot of players in the space. You have New Relic, and before New Relic, there was folks like Dynatrace, and you have newer folks like Datadog. But I think the point is that infrastructure is constantly changing, and I think you need the right tools for the right infrastructure that you're using. So when we're using something like Kubernetes, where containers are such a big part, and container orchestration is such a big part of Kubernetes, you need tools that help define container maps, container specs. Some notable partners and folks that we've talked to, or tools and open source tools that we talked to, is Prometheus is obviously one of the bigger ones. Sysdig is a great company that does a lot of good stuff around Kubernetes, and the APM provides a good APM for Kubernetes, and has gone even beyond that to provide some security tools for Kubernetes and other infrastructure. And then you have folks like Instana as well. And again, part of their evolution here is that they're making very specific tools for some of the newer infrastructure to provide better tools. I mean, as infrastructure changes, you need better tooling that's fit for that specific thing. You can't necessarily compare something like VMware to Kubernetes. And so similarly, the same tools that work well for one thing may not work well for the other. And then secondly, from an evolution perspective, if you're looking really far into the future, machine learning becomes a huge deal for APMs as well. They can identify patterns, detecting issues proactively. And it's, you'll see machine learning as a topic that trends kind of across all these, all the different spaces, as we can always have something in the back end learning and constantly improving things for us as far as the tools are concerned. So metrics. If you're not familiar with metrics can mean a lot of different things, like I mentioned before, but really the way that we look at it from a DevOps observability perspective is you use metrics to track and analyze your own application metrics. And this is highly customizable and meant for out of the box. Oftentimes metrics could mean tracking for product reasons. You could be looking at growth, but you could also be using metrics with things like Grafana, where you're piping metrics into Grafana dashboards so that you can see whether or not something is behaving correctly. So a good example would be something like tracking your heartbeat for your application. You may have a small microservice that's just pinging something here and there and detecting whether or not it's alive to make sure that things are going well. There's a lot of different metrics here. Example for us specifically internally is that we need a way to determine what our live tail latency is. And so these are metrics that we effectively build into the system so that we have a good way to track that and we can provide that information out to our customers. The metric solutions are generally a little broader. There's a lot of ways to build them open source, and there's a lot of different databases that are built to effectively handle or gather the right type of data so you can do the right type of analysis. At the end of the day, it's really KPIs for your organization and also down to your application, and sometimes even down to things that you're getting from APM. So if your APM is collecting CPU stats and you want to take that information and be able to provide historical information around that, then you want a metric system to be able to handle that. A lot of metric systems, you want to be able to determine user behavior, define trends in usage. And again, you want to be able to track your application performance historically. The whole idea behind all this is you want to gain insight to what either features are frequently being used and understand what makes your customer happy, which is at the end of the day, the most important thing is how do these tools allow you to provide a better product and a better solution for the customers that you have today. And metrics is a way to do that in a very less generic form. These aren't canned dashboards. These are things that you create yourself. These are KPIs that you create yourself to be able to analyze that. All right, so jumping into logging. If you don't have a logging platform in place, generally you know what logging is because you have applications that are generating errors. But the whole idea behind a logging platform is that we want to be able to collect structured and unstructured data to use as an audit trail for root cause analysis. So here's the key point is that there are a lot of tools today. So we talked about APMs and we talked about metrics, and these all will let you know that something is potentially wrong, but you won't be able to find out what's wrong until you can dive into your application and find that root cause analysis based on the logs that are happening. And so oftentimes logging will be sort of this last thing, like I don't really want to go look at logs, but I have to go look at logs. And so when you do go look at logs, you want a logging platform that can help you search for specific logs and set up alerts based on these logs to get notified and identify these patterns before users are impacted. So when I say set up alerts for logs, why that's important is because once you've defined that, hey, this error is really important, I've found the error that's causing the issue, and I can pinpoint that this error can be used over and over again to alert myself that, hey, if this error occurs, I should know so that I can go in and fix something. So oftentimes, there could be a lot of things that cause CPUs load. You're constantly, with companies today, a lot of folks are doing continuous development or continuous deployment, so CI/CD, where a lot of new changes are going on. So it's really hard to tell what exactly could be causing higher CPU load, higher network load. It could be a variety of things. But I think what's important is that if you've identified a failure or an error that has happened before through your logging, then you can also set up those patterns to be alerted later on in the future. So even if your CPU load's high, I get an alert based on my logging system that, hey, this specific error is coming back and a regression is happening, then I can immediately be able to tell what has happened in my system. And I can set that up for zero failures in the future because I can identify that before that even happens. So a logging platform should allow you to do that. And then lastly, this is kind of just a regurgitation of what I've been saying before, is that, the ability to dig into root cause analysis by analyzing the actual audit trail events at the time of failure. So oftentimes you may just get that error, but you want to be able to look at step-by-step sequentially what had happened to cause that error. And that's often just as important as, defining that error itself. You want to know what happened before, and you want to know what happened after, and you want to be able to replicate that. So the only way you can replicate that to make sure you're getting the same, not only just from a performance behavior perspective, is that you want to be able to look at the logs and say, hey, sequentially, this is the same thing that's happened. And that's allowed us to determine that, yes, this is the same error that has happened and we can fix it, go in and fix it or find a solution on how to fix it. So why is logging so hard in general? And when we look at it, why we believe there's a lot more evolution from a logging space than there is kind of anywhere else in the observability space. Well, I think logging is hard because data can be structured and unstructured. So we're not talking about, a single metric that comes in and we know it's a CPU, usage percentage that's going to come in every single time. Data that's coming in from a logging platform perspective, it could be anything. It could be structured, it could be unstructured. New applications could generate anytime developers are adding new features and functions. Those logs could look different because they want to add a couple more things. So it's difficult because it's unpredictable. And that unpredictability also lends itself into log volume. It's hard to measure and predict. We talk to a lot of customers today which have a lot of difficulty when we say, well, how much log volume do you think you're going to have so that we can scale the servers up for your deployment? And a lot of times it's, I don't know. And so we have to run through a series of tests where we have them send us all their logs from a fire hose perspective, and then we help them determine what is the right solution or what is the right volume that they need to anticipate or expect. And then on top of that, we still have to expect surges or spikes when traffic is extremely high, or they've introduced potentially a bug that's causing additional logging, or if there's just additional traffic into their website for any particular reason based on what they're doing in the application. Next, logs are unique to each application organization. Outside of things like Nginx logs and CDN logs and network-based logs, there's not a whole lot of ubiquity across anything outside of just format specific logging. So what that means is that every application that's built, they may want to save different variables and environment variables or parameters directly into the logs, and so they do it. And that makes it very difficult to scale as well, because you're not, again, from a data structure perspective, you're not just storing a single thing over and over again, and you can optimize for that. You're storing effectively a lot of different types of indexes, a lot of different types of searches. And then going in terms of a usage, logging systems are hard because most users don't need to see all the logs. Most users are just concerned, and developers are just concerned with their application logs themselves. And so you need to be able to find an easy way to provide an interface where developers can just access the logs they need to access versus wasting their time searching through tens of hundreds of different indexes on, hey, are my logs here, or am I looking at the right server? These are all issues that make building a good logging system very, very hard. And then lastly, it requires a lot of unnecessary and unwanted storage. This goes back to, logging is used as root cause analysis for a lot of issues and digging deep, and can oftentimes be used for metrics. But that means we're storing a lot of information that only gets tapped into when potentially something's wrong or you're trying to improve or make something more efficient. Meaning that for the majority of the time, you may not need that storage, you may not need that logging data being streamed in, but you need to have it there in case something does go wrong. So in terms of logging, I wanted to look through a really quick example of how logging evolves and how logging can get better. And I'll take Kubernetes, for instance, and I'll explain a little bit more about Kubernetes if you're not familiar with it. So in Kubernetes today, they have this hierarchy of node, pods, and containers. And so containers, I think you're all familiar with, Docker containers, you're running services in Docker containers. And the way that Kubernetes kind of structures it all is that there are nodes that are running, and these are physical servers or physical VMware boxes or images that are running. And these are actual servers and operating systems themselves. And then within those nodes, you have pods. And inside these pods, you have containers. So it splits them off into these very distinct these distinct hierarchy of how they're running these containers. And it's very good at orchestrating when something needs to scale, it can create new pods and new containers. And when something doesn't need to, it'll do what it needs to do to terminate and clean what it needs to clean. So the way that Kubernetes natively handles logs is that you have a node, and in that node, there are pods and containers that will basically log directly to the local file system. But the problem here is that when it logs to the local file system, at any time this container, if it terminates, or if the pod is evicted, then you lose those logs automatically. So there's no way of handling that, and there's no way of keeping those logs. And so it makes logging very difficult, because in case those pods end up dying, you have no way of getting those logs back. So a sample of better Kubernetes logging is there's something called Fluency. It's a very popular open source, and it actually has a plugin directly into an Elk stack. And so you can actually use Fluency today. And what you do is you configure it, and it runs as a daemon set. What you do is you configure the Fluency config of telling it what kind of logs you want. There's a lot of configurations you can do. And then it'll go through the Fluency agent, and then also obviously then pipe that into directly into Elasticsearch, where you can then use Kibana to search this information through Elasticsearch. And there's not really a whole lot of optimization there. Any optimization you're doing there is customized. It's based on what you think is good for the logs. And then you look at LogDNA, and what we've done here is since we are huge proponents of Kubernetes and we use it all the time, we actually have built something where the LogDNA agent will actually automatically take the logs and enrich those logs with information that you want. So you may be, your Kubernetes line may be sending us one line of logging, but what we're going to be doing in the back end is we're going to be adding labels and tags and adding additional metadata so that you can find this. So even if your containers or pods die later on, you're still going to be able to find that information directly into the logs that get enriched with what LogDNA does. So just part of improvements in the infrastructure, things that you can make, ways that you can make logging better for whatever tools that you're using today. And it's not just, hey, let's just centralize these logs and you don't need to be stuck with this. It's definitely something that us as a company and all the partners that we're working with in the DevOps observability space are trying to do is find ways to improve the tools that we're building. So how can we evolve logging in general? Deeper integrations. So this is an example that I just went through. So with Kubernetes, we're spending a lot of time building deeper and more robust, more meaningful integrations. So things like adding metadata, adding tags, adding colors. We're doing this on purpose because we want to make your life easier. Again, the whole idea here for logging is that it doesn't have to be, or we don't want it to be something that you're spending a lot of time maintaining or trying to figure out how to use. Logging should just be simplistic in terms of we do all the work for you, and you should be able to find the logs that you need to find as soon as you can. Machine learning. So what's important here, and what works well from an aggregate perspective, is that we can use machine learning now to detect and raise flags when new patterns and formats are detected. So a good example of this is a lot of folks are doing a lot of things in the security world. Now, today, we're mostly focused on kind of DevOps use cases, troubleshooting, debugging, but you can imagine a world where you have a lot of logging and you could use machine learning to detect whether or not a critical bug or something has been introduced into your system based on what's been discovered out there. So an example could be when the TLS bug was introduced about a year and a half, 2 years ago. LogDNA can automatically say, hey, look, we've detected that you're running on TLS 1.0 and you need to upgrade your system. Otherwise, you are vulnerable for the system. So you don't want to get as far deep as to doing virus scanning or anything like that, but it does give you that ability to say across the board, here are some trends and patterns that we're seeing to help facilitate use cases for a lot of our customers. And again, the more data that we get, the more customers that we start piling on, the better some of this stuff gets as well. The other thing that we can do with machine learning, and we're already doing this from a services backend perspective today, is that we intelligently parse your logs. And so what I mean by that is, if you're familiar with any logging solution out there today, generally what you have to do is you have to configure the inputs and outputs of the data that's coming in and data that's getting pushed out to your logging solution. Meaning that you're deciding on the spot and configuring, hey, this is how my data should look. And it's a lot of work. It's not easy because you're taking unstructured data sometimes and you're trying to format it into a way that makes sense to you, and you're spending a lot of time. LogDNA, for example, we do a lot of this in the backend for you. We say, hey, here are the 20, 30 formats that are open source and generalized, and we will automatically do those formats for you. And then as other folks parse and create rules for their own formats, we can take that information and optimize that for other customers as well. And so that's just a way to make DevOps lives easier, is that they no longer have to actually think about parsing logs or information that's coming in. LogDNA or a logging solution in the backend can do this for you and do it very, very intelligently because other folks are trying to optimize the same thing. The other thing you can do is, obviously as a log platform, is we're sitting on a lot of data. So it's unstructured instruction. And so there's a lot of big data purposes we can do with this. Some of the things that we've been thinking about are from an architecture perspective that makes a lot of sense, is that, hey, sometimes you don't want this data just to go into a searchable table. You want to be able to use it for other things like alerting, or you may have webhooks and other integrations that we're doing. So from an infrastructure perspective, what we've built is we've actually separated our pipelines, one that goes into search once data comes in and one goes out to live tail. So that gives you that immediate real-time feedback of logs that are coming through, and it gives you the familiarity that you want to get as a developer that's doing a tail-f on logs. So you get that warmthness, but then also we can use that data in other streams as well. So that gives us the flexibility of not just collecting data to search, but as we build more and more tools on top, it may go out to customers may have requests where I'm running an SIEM tool and I need data streamed out to that SIEM tool. So interesting things on how logging solutions can evolve outside of just being a search database. And then lastly, flexible deployment. And I talked about this a little bit earlier, but it's really a pick your own deployment strategy that we want to provide. So luckily, I would say because LogDNA is run on Kubernetes, it's given us the ability to then package up our entire cloud native solution and deploy it in an on-prem perspective. What that now gives you customers the ability to do is that they no longer have to rely on just, hey, I want to run my own stack, or I want to run in the cloud. I have that, we have that flexibility in our solution that says you can do either or. And then I'll talk about multi-cloud in a little bit, which is an evolution on top of that, which allows you to have even more flexible type of deployment as well. But the flexible deployment gives you compliance with data locality requirements. So if you have offices based in the EU where GDPR and privacy concerns are an issue, or anywhere else, you can deploy there versus running a multi-tenant SaaS in the US. And then lastly, this ties again back into multi-cloud, which is we want to be able to have a single search interface no matter what the no matter what the deployment is. So if it's flexible in terms of you're using an on-prem deployment and also a cloud-based deployment, then you should still be able to search across that entire stack. So modernizing logging deployment, we touched upon this on the last point, but the idea here is that we have on-prem or private cloud, so we can actually deploy a full instance of a logging solution directly onto whatever infrastructure you want. Just to clarify that too, is that when we say on-prem, or when I say on-prem, I'm not specifically saying this has to be a bare metal server sitting in a co-location facility or sitting in your data center. On-prem could also mean directly in the public cloud within your own infrastructure. So there are a lot of customers that we have today that are like, hey, look, we want a private deployment of this stuff. And actually, it's really easy for us because we run on cloud in general. So all you have to do is give us credentials, and we can go deploy the infrastructure out. You're paying for your infrastructure. We'll help you scope the size of what that looks like, and we can deploy directly. And that happens a lot faster than having to send an engineer to a data center, waiting till the servers are up and logging in and installing it from that perspective, and then having network issues there. It's all very easily done through the cloud into any infrastructure provider that you have. Private cloud's a big one too. So we work with a lot of partners and organizations that want to deploy private instance of it. Not too different. It's just that they have private clouds that they're working on, and just showing you that it's pretty much one and the same for a logging solution like ours. And then we have cloud, which is I think everybody understands it's a multi-tenant SaaS that we're running. The interesting thing about our cloud services is that we have the capability of running services across multiple different clouds. So today, if you're, let's say, you're running on AWS and you're interested in not spending a lot of egress costs going out to where the majority of our servers are on in a data center, then we can run services directly on any cloud provider that you have today to lessen that egress cost. So just some flexibility there. And then lastly, multi-cloud, which is the ability to effectively have a single search interface, so connecting multiple deployments and multiple tenants of a logging solution. So you may have your own single tenant that's running on your own on-prem instance, and then you have for dev and test. Here's the use case that we see for dev and test. You may not want to pay for additional infrastructure on your own, so you just want it to run on our SaaS, and we offer pretty competitive pricing there. And so you want to be able to search across both dev, test, and also prod. And multi-cloud allows you to do that because we combine those services and combine that data pipeline together to allow a single interface into that. So the shift to multi-cloud, why want to bring up multi-cloud is we're seeing this more and more. And it first started with customers saying, hey, we needed some privacy concerns, but we really wanted the scalability and the flexibility of having a cloud native solution, which wasn't really available at the time. And so we kept thinking about it, we're like, hey, we can actually do this because we do Kubernetes stuff, which allows us to shift into, multi-cloud means a lot of different things, but for us, it really means just ultimate flexibility. It gives you the flexibility of where you want to deploy. It gives you the flexibility of cost. It gives you the flexibility of data governance, security, and compliance. So if you want to, you want to run, again, things in the EU on-prem, but you want to run things in our multi-tenant SaaS in the US, you can do that, and you can still allow customers today to search across those two interfaces, but keeping the data private on where it needs to be kept. And again, it lowers your total cost of ownership because you can decide, again, how you want it deployed in whichever fashion you want. So overall, it doesn't have to be an all or nothing type of solution. So the last two slides that I'll go through are just quick use case or customer scenarios that we have from our customers, just to show why they chose us in terms of what we provided for them as a newer, more modern logging solution. So for Instacart, which is one of our largest customers, their previous provider wasn't able to meet expectations in terms of live tail. Actually, they really like live tail and the searcher speed, And we've done a lot of optimization in the back end to make search of speed a very elegant and usable solution. But Livetail is a big thing. I think Livetail represents for a lot of developers the idea that the logs are actually flowing through, and I don't want to see Livetail based on a database replay of what's come into the database and you're playing it out. I actually want to see it live in the stream so that I know that in real time this is actually what's going on in our systems. And so what we really ended up solving for them, if you look at their scale of deployment, is it's huge. They operate in 1,200 cities. They're a very large company doing very well. They have 50,000 plus shoppers in any given week. And what we solved is, Livetail, search of speed, and we really lowered their overall total cost of ownership because they didn't have to run their own elk stack anymore in the background. Linebike, they've obviously recently been participating in the huge scooter fad, and these guys, huge IoT players in the space. And so they had huge scale, and they, in terms of seasonality, they get traffic in huge rushes. And a lot of this traffic is not only coming from their application servers, but you can imagine every single device that they have connected out there is sending logging back. And they need to record all that logging to help them determine from a customer support standpoint, is something wrong with the devices that we're sending out there. And again, they're just constantly expanding on it. So any given time, they're throwing hundreds of different devices, bikes, and scooters out there to deploying into new cities and things like that. And so they have rapid growth. They needed a company that could handle the data spikes that they were doing, and we could do that by allowing them to scale and provision more and more nodes as they needed them. And their time to value with fast onboarding was our solution was really easy to use. And so it wasn't this solution where it took them weeks to train up on new query language. They were able to go in there and find the logs they needed to find, and the speed of search was really, really important to them as well. And then my last slide, just going through the whole evolution of logging and the whole evolution of DevOps tools, is really you need the ability to scale with the tools that you have. You want real-time access and you want flexible deployment across infrastructure because that's changing. It's no longer just servers, and that's changing fast and rapidly because everything is getting extrapolated out to effectively these containers and the serverless idea of like not even having servers anymore, or not even running operating systems. You're really just deploying code out there. So you really want flexible deployment. You want access and search across multi-cloud. And the reason for that, again, it goes back to flexible deployment. You have a lot of your different infrastructure running on different types of things. You may have things running on Heroku. You may have things running on AWS. You may have things running in-house. You want that ability to search across multi-cloud, and then machine learning should be part of the evolution as well, is that we have all these great services coming from IBM, like Watson, Microsoft, Google. We should be able to use these machine learning services to enhance the tools themselves and make it even better for our customers today. I think that was my last slide. Thanks, everybody.
All right, we'll go ahead and go into the question and answer period of today's webinar. We have gotten some questions in so far, but there's plenty of time. If you have a question for Norman, please go ahead and use your GoToWebinar control panel and get those questions in, and we'll go ahead and kick off with the first question, which is, would like to hear what your definition of observability is. So if you could clarify that.
Yeah, sure. Observability to us is it's not too far from the word, but it's the idea that you should be able to monitor your system from a high level and be able to determine the health of your system based on the tools that you're using. So again, if logs aren't coming through, then you know that, hey, my application may not be running. Using an APM, if I can tell whether my CPU loads are high, it's that idea for you to, as a DevOps person, to be able to encompass what's going on and use that information to determine how well your applications are running or how well your infrastructure is running at that time.
Okay, all right, great. Next question, could LogDNA be used as a more intelligent SIEM? Could third-party partners and customers use LogDNA APIs to grab data and do further analysis?
Yeah, that's a great question. So today, LogDNA is focused primarily on troubleshooting, debugging as a DevOps tool. As you get into the SIEM space where you're talking about security and event management, you could. We don't have the plugins today to do it, but we can actually, there are partners today that grab our export APIs and take that information and analyze that from a forensics perspective and analysis. one thing that we're building that would help this is when you're oftentimes talking about SIEM, you're probably talking about more real-time alerting from a security perspective. So what you want is a real-time stream of information that's coming through. So we are building Firehose-based functionality where we could actually pipe directly. And so you could say, hey, from these systems, we want to pipe this data directly to our own SIEM system and not get charged for backend Elasticsearch storage. But for this data, we want to store that because we want to use that for logging. So we will have that functionality. But today, you can use our APIs to do it, but we don't have any built-in SIEM tools ourselves.
Okay. All right. Great. Next question. Let's see. Configuring log parsers is always a pain. What are your thoughts on log parsing and how should a solution handle that? And then does LogDNA do that inside the container before the logs are forwarded or done in your servers in the back end? And finally, what about unique or special formats we need parsed? That's a lot of information there.
Yeah, okay. If I remember the question correctly, in three parts. So thoughts on log parsing and how should a solution handle it? So there are a lot of solutions out there today, and a lot of the legacy solutions, incumbent solutions that basically require you to create, structure out the input. So you tell the system what you're sending in, and then you tell it how it should format it out. In general, I think I talked about this as developer first type tool. We don't believe in that because we believe systems are much smarter in determining some of that. So for us, we have services in the backend that do that for you. And if you're not happy with the way that we're parsing it, we have what's called a custom parsing engine that will allow you to then take what we've done and then delimit that or parse it or cut it in a way that makes sense for you and your organization to use. I think the second part of the question was, do we do that inside the container? You can. So if you look at like Fluency, they obviously do that as a configuration. You're doing that, but again, for us, we just take that data, we enrich it because we're already running agents on the system. We can do that for you. The other thing that I'll mention is that we have an API which allows you to send metadata directly. So if you want to create logs that have JSON formatted metadata and you want to make those fields searchable, we can take that information as well. So very flexible in the way that we ingest logs. And then I think I answered the question earlier about unique special formats. We do have a specific parsing engine. It's a GUI-based interface that will let you to cut and basically take a log line, and then you can basically split it up visually and then determine if a format looks good to you. And then from that point going forward, if you apply that rule, it'll format all the logs in that specific manner that have matched that query.
All right, great. Just a reminder, there's still time if you have a question for Norman, go ahead and use your GoToWebinar control panel. We have one more question here, and if we don't get any more in, then we'll go ahead and close it out. But here it is. We have multiple Kubernetes clusters for dev, test, production. How can we uniquely identify the logs coming from each if the environment if the pod containers names are all the same?
Yeah, it's a great question, and we often have to work with customers that do this as well. Obviously, when you're deploying Kubernetes, you're sort of just mimicking each deployment, and everything ends up being named the same. And so for the agent that we deploy, it's a daemon set for Kubernetes specifically, and within each daemon set that you configure, you can actually configure very specific tags that go along with each of the logs themselves. And so even though the containers and pods names themselves, there's another high-level tag that'll allow you to identify whether this is a dev, test, or production environment, and then you can filter those logs based on those tags as well, so that you can easily just click, hey, I only want prod logs for this Kubernetes, for this deployment, and I will only see production logs or only see test logs or dev logs.
Okay. All right, great. Well, we haven't gotten any more questions in, so we'll go ahead and close it out here. I do want to thank everybody who did submit audience questions. Also want to remind the audience that today's event has been recorded, so if you missed any or all of the event, you will be able to access it on demand. As I said earlier, an email will be coming your way very soon that will contain a link to the webinar that you can click on to listen to it on demand. The webinar is also going to be living on the DevOps.com website, so you can always go there, check it out. Just go to the webinar section, look under On Demand, and it should be there waiting for you. And while you're there, go ahead and take a look at some of the other webinars that we have both upcoming and on demand. Hopefully there'll be some that pique your interest. Norman Shu, thank you so much for giving such a great presentation. I know the audience got a lot out of it. I did as well.
Yep, thank you very much.
Great, thank you. And I want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day.